Hello everyone. We're going to look at section 3.1, which is called the product and quotient rules. These are some important derivative rules. If you haven't figured it out by now, derivatives are absolutely the most important thing we do in Cal 1. The biggest issue I've seen with this section in the past is people try to go too far. All we want you to do is apply the rules and stop. You don't have to do any simplification. Okay, so let's start off with the product rule. Simply put, the product rule is when you're multiplying two factors and you want to take a derivative. Okay, so for example, if I have something like this, f of x equal, I don't know, 3x plus 9 times 5x minus 8 or something like that. I've got something with x times something with x. I'm multiplying two things with x, so I have two factors. The textbook definition that they would give you would say this: if you have something in the form y equal f of x times g of x, where f of x would be like the first parentheses here and g of x would be like the second, then the derivative would be f of x times g prime of x plus g of x times f prime of x. And that's all good and well. Again, that's the textbook definition, but there's an easier way to remember it. And the easier way is just with a mnemonic. So instead of thinking about this as f of x times g of x, what if we thought about it as the first factor times the second factor? First times second. So 3x plus 9 is first, 5x minus 8 is second. And then the derivative would be first times the derivative of the second. So I'm going to use d second to indicate derivative of the second, plus the second times the derivative of the first. And we can stop right there. This is the same thing that they're saying here on the left side of the screen, just in a bit more layman's term notation. Most people remember this rule with this mnemonic: first d second plus second d first. There you go. So for example, this problem, if I wanted to do the derivative, it would be first 3x plus 9. Again, that's first. Then we need to multiply times the derivative of the second. So the derivative of 5x minus 8 would be 5 plus second, which is 5x minus 8, times the derivative of the first. Okay, so first is 3x plus 9. The derivative of that is 3. And that would be my solution. Don't try to simplify it. The only time you really have to simplify is later on when you're going to be solving for x, like you set this equal to something and try to solve. But that's just part of solving an equation in algebra, so you probably don't even think about it as simplifying. Just leave it like that. Okay, so let's go over here to Hawks and take a look at what they have. So again, this is section 3.1, product and quotient rules. The first several questions that you're going to see are product rule questions. So if you look at this, use a product or quotient rule to find the derivative. We have x to the negative 1/2 times 4x to the 3/2 plus 4x to the negative 1/2. That's the same setup as the problem I just worked. It's just you have these ugly fractional exponents. But it's not a big deal. I mean, we don't do anything any different. It's still that same rule. So let's see. Let me write this down on my other screen before I flip back. Okay. All right. So there's the function. We have x's times x's again. So you can call x to the negative 1/2 first, and the parentheses 4x to the 3/2 plus 4x to the negative 1/2 second. All right, and let's go through and apply the product rule. Okay, so first, x to the negative 1/2 times the derivative of the second. Okay, so we need to take the derivative of what's in parentheses there. So use the power rule. 4 times 3/2 would be 12/2, which is 6. 3/2 minus 1 would be 1/2. Okay, the next term, 4 times negative 1/2 is negative 2. And then negative 1/2 minus 1 is going to be negative 3/2. Okay, so I'm just using the power rule there. Plus second. Okay, so that's just rewrite what's in that second, that parentheses there. 4x to the 3/2 plus 4x to the negative 1/2 times d first. Okay, so the derivative of x to the negative 1/2, so that's going to be negative 1/2. X to the negative 1/2 minus 1 is negative 3/2. Okay. And stop there. Don't go any further. The biggest issue we see people make on the tests with this is trying to multiply all that out. You know, you mess up on your exponents or something like that. You don't have to do that. Just leave it. Apply the rule and stop. Okay, so I'm going to flip over to the other screen, and I'm just going to type in what we had written there. So x to the negative 1/2 times 6x to the 1/2 minus 2x. Oops, excuse me, I hit the wrong button. Minus 2x to the negative 3/2 plus 4x to the 3/2 plus 4x to the negative 1/2 times, negative 1/2 x to the negative 3/2. Okay, so that's exactly what I had written out on the other screen. Do not simplify. Go ahead and hit submit. That's correct. Again, you do not have to simplify. This is the same on the homework, like I have pulled up here, and it's the same on the quizzes and the tests. Apply the rule and stop. Don't worry about the simplification. We're not asking you to do that. We're grading the calculus part, not the arithmetic part, if you will. So there's our first example. This is going to be the same thing. The numbers are a little nicer there, so I'm not going to do that one. Let's see if we can get, something like this. It's a bit uglier. Notice on this one, you have variables in the denominator. If you remember back to chapter 2, when you learned the power rule, you learned that the variables always had to be on the top. So before you try to apply anything as far as the product rule goes here, you need to rewrite it with your variables on top. So hold on, I'm almost finished rewriting this. Let's flip our screen. Okay, so there's our problem. Alright, so you can move variables up or down all you want as long as you change the sign on the exponent. So again, I'm not doing a derivative yet, I'm just rewriting this. For 4 over x to the 2/3, push x to the 2/3 up. It becomes 4x to the negative 2/3. For negative 3 over x cubed, push x cubed up. It becomes negative 3x to the negative 3. And your next parentheses, negative 2 over x cubed becomes negative 2x to the negative 3. And then there's nothing you got to do with minus 5. So rewrite it in that form where your variables are on top. Get them out of the denominator before you try to do any derivatives. Okay, and we can call this first and this second, and we can do the product rule again. So first is just that first parentheses, 4x to the negative 2/3 minus 3x to the negative 3. Then we need the derivative of the second. And so the derivative of the second parentheses. So negative 2 times negative 3 is 6x to the negative 4. Derivative of negative 5 would be 0, so that's gone. Plus second, negative 2x to the negative 3 minus 5. And then d first. So 4 times negative 2/3 would be negative 8/3. X to the negative 5/3. Let's say negative 3 times negative 3 would be positive 9. X to the negative 4. So again, we're just doing the power rule inside those parentheses there. Again, don't simplify. Leave it like that. Let me flip over here and type that in. And so we had 4x to the negative 2/3 minus 3x to the negative 3 all times 6x to the negative 4 plus negative 2x to the negative 3 minus 5. And then that last parentheses was negative 8/3 x to the negative 5/3 plus 9x to the negative 4. There we go. Just typed in exactly what we had written out on the other screen. Don't simplify. And there it is. So it's actually pretty simple once you realize you don't have to try to simplify the answer. Apply the product rule and don't go any further. That's basically the same thing. Let's see. Here's a case where you have a word problem. Notice they have something with x in parentheses times something with x in parentheses, so that's going to indicate the product rule again. And then ultimately all you're going to do is plug in an x value at the end and round to the nearest cent. So cost of producing x items of a product is given by that function. Find the marginal cost when x is 79, round to 2 pennies basically. So we can go ahead and do that one, and then we'll look at some quotient rule problems. So got 0.28x plus 20 times 0.28x plus 10 minus 200 Okay. So there's our function. Let's go ahead and get our derivative. Okay, so again, we're going to call this first and this second. So first is 0.28x plus 20. Derivative of the second is going to be just 0.28 plus the second, which is 0.28x plus 10 times the derivative of the first, which is also 0.28. Okay. And don't forget, you do have this other term here, but it's just a number, so the derivative of any number is 0. Okay, so that term is gone. Okay, so there's your derivative. You could try to simplify if you wanted to. I don't see any point in doing that. All that's left would be to plug the x value in a calculator. So if I flip back over here, it said find the marginal cost when x is 79. Okay, so we're just plugging 79 in for x. So let's do that. C prime of 79. So 0.28 times 79 plus 20 times 0.28 plus 0.28 times 79 plus 10 times 0.28. And I'm just going to type that in a calculator for us. 0.28 times 79 plus 20 times 0.28 plus 0.28 times 79 plus 10 times 0.28. Okay. plug that in a calculator, I get 20.7872. So remember, it said round to 2 decimal places. It's money, right? So the pennies. So make sure you write that as $20.79. And let's put that in. $20.79. There it is. Alright, so again, just make sure you round to pennies here. Same thing, it's population instead of a cost problem, but same exact idea. You want your derivative, and you're going to plug in 12. That's really all you got to do there. Okay, equation of the tangent line. Some people had issues with that I've actually been emailed about. So I want to do one of these. Notice they give you a function and they give you a point. They want the equation of the tangent line at that point. Remember, a tangent line is a line that touches the graph at exactly one point. Specifically, in this case, this point, 1, -12. So the idea is you need to get the derivative, plug in that x value to get your what we call our slope, and then we can go back to algebra and use what's called slope-intercept form. We want to write our answer in that form. And so let me write my function down here. F of x equal 3x squared minus 4x minus 5 times negative x squared plus 3. Again, we've got that point, 1, -12. Let me flip over. So again, product rule. That's why it's in this section. Go ahead and get your derivative. First times d second plus second, which is negative x squared plus 3 times d first. So derivative of 3x squared is 6x. Derivative of negative 4x is negative 4. Derivative of negative 5 is 0. So there's your derivative. You want to plug in your x value here, 1, to get what's called your slope. That's really what a derivative is the slope at a single point. So plug in 1 for all those x's. 3 times 1 squared minus 4 times 1 minus 5 times negative 2 times 1 plus negative 1 squared. Notice the negative sign's not squared there. Plus 3 times 6 times 1 minus 4. Let's see, let's simplify a little bit. That's 3 minus 4 minus 5. It's negative 6. Negative 2 times 1 is negative 2. Over here, negative 1 plus 3 is 2. 6 minus 4 is 2. So you basically have 12 plus 4, which is 16. Okay. So this is the value we get from our derivative. Okay. So this is what we're going to call m. There's a formula in algebra that says this. Y minus y sub 1 equals m times x minus x sub 1. That's called point slope form of a line. M, that's the slope, that's what we just got from that derivative. So m is going to be 16. So let's go ahead and plug that in. That's 16. You also want to plug in for x sub 1 and y sub 1. And those are just going to be from the point they gave you. They gave you a point 1, -12 here. So x sub 1 will be 1, x sub 2, or excuse me, x sub 1 will be 1, and y sub 1 will be -12. And if you notice on Hawks, it's already got y equal here. So basically all you're doing at this point is going through and getting y equal on one side. So really you have y plus 12 equals 16x minus 16. All we got to do is subtract 12 over. So negative 16 minus 12 is going to be negative 28. So there's the equation of the tangent line. 16x minus 28. There we go. Okay, that should get you through the product rule questions. The other part of this is quotient rule problems. So notice here, instead of multiplying things, we're dividing. You have x's over x's. Okay, so let's go back over here to our other screen and talk about the quotient rule for a minute. Okay, the formal definition you'll see for the quotient rule in the book would be this. You've got f of x over g of x, basically something with x over something with x. And the way they describe the rule to get the derivative would be this. They would take g of x times f prime of x minus f of x times g prime of x all over g of x squared. Well, again, that's formal definition, but there's an easier way to remember it. There's a mnemonic for this as well. Instead of thinking about f of x and g of x, let's just call whatever's on top high, whatever's on bottom low. High and low. So our derivative would be low times the derivative of high minus high times the derivative of low all over low squared. Now that sounds really weird, but if you say it a whole bunch of times, you won't forget it. Low d high minus high d low all over low squared. Make sure you have low d high written first. Big mistake on the quotient rule is people will reverse that numerator, and your answer will be wrong then, because your sign's going to be off. So it's got to be low d high first, then minus high d low. It's got to be in that order. Alright, so let's take this problem they've given us here. Negative 8x squared over negative 7x to the fifth minus 7. So in the same fashion that I just showed you, we could call negative 8x squared the high part, and negative 7x to the fifth minus 7 as the low part. Again, that's high over low. And apply that mnemonic we said. Low d high minus high d low over low squared. So low is the bottom, going to 7x to the fifth minus 7 times the derivative of high. So the derivative of negative 8x squared, that's negative 16x, minus high, which is the top, negative 8x squared, times d low. The derivative of the bottom would be negative 35x to the fourth. Derivative of negative 7 is 0, so that's gone. So low d high minus high d low all over low squared. And so we just take the denominator, whatever it is, put it in parentheses, and raise the whole thing to 2. And again, just like with the product rule, you do not have to simplify. Just leave it. Type it in exactly like that. So I'll show you over here on Hawks. We had low, which was negative 7x to the fifth minus 7 times d high, which was negative 16x, minus high, which was negative 8x squared, times d low, which was negative 35x to the fourth, all over low squared. So again, the whole denominator put in parentheses, Do not simplify. Just apply the rule. Stop right there. There we go. That's correct. Alright, let's do one more of these. That's pretty basic. Okay, something with a fractional exponent. That really doesn't change anything. We can still do the same mnemonic. In fact, I'm not even going to write it down this time. We need a fraction. So low is going to be the bottom, negative 4x squared minus 6. High is going to be the top, 2x to the 1/3 plus 4. Our mnemonic was low, negative 4x squared minus 6, times the derivative of high. So the derivative of the numerator there. 2 times 1/3 is 2/3. X to the 1/3 minus 1 will be negative 2/3. Minus high, which is again the top, 2x to the 1/3 d low. So the derivative of the bottom, so the derivative of negative 4x squared would be negative 8x. Of course, the derivative of negative 6 is 0, so that's gone. All over low squared. So put the bottom in parentheses. Raise it to 2. Low d high minus high d low all over low squared. There we go. Alright, and you see these are, there's not a whole lot of difference in these quotient rule problems, so apply the same thing. Okay, post on the discussion board if you have questions, and I'll try to address those there.